Hello, so today we're going to be looking at trigonometric ratios. So first, let's recap the primary ones. So first you have sine, which you can notate as sine theta with this as the angle, and cos theta, and the tangent is tan theta. Sine theta is opposite over hypotenuse. So first, let me just recap this. So the opposite would be opposite the angle, and the hypotenuse would be opposite the 90 degrees, and the other side is the adjacent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now let's look at these inverse ratios. So first we have cosecant, which is cosec theta, which is just the inverse of sine theta. Secant can be written as sec theta, which is the inverse of cos theta. Then we have cotangent, it can be written as cot theta, which is the inverse of tan theta. Now let's look at something that will help you find the sign of the ratio depending on the different quadrants. So we'll start writing CAST, starting from the bottom right. The next goes on the top, and the one next left. So this is the cast rule is, so what this C says is that cos is positive. This A says that all of them are positive, and this one says that sine is positive, and this T says that tan is positive. So for example, if you take this angle, then you know that the sine theta would be positive. But if you take the tan of this, it would be negative because only sine is positive here. But over here, sine, cos, and tan, all of them are positive. Now let's try doing an example. Analyze the scenario. So cot A is root 5 over 2. Sine A is negative. And let's try finding cosec of A and sec of A. So first let's see where the angle A can lie. So first let's use the cast rule. So CAST. So they're saying that cot A is positive. So cot A is positive, and cot is the inverse of tan. So if cot A is positive, it means that tan A needs to be positive. Because 1 is just 1, it's just already positive. The only way this can be positive is tan needs to be positive. So tan is positive over here and here, but not here and here, so we can cancel these out. Next, sine A is negative. So sine A is sine A. Let's see where sine A is positive first. Sine A is positive over here. It cannot be this. And this, and it's already struck out, and here also is negative, so it can be negative here, but we already crossed it out over here due to the cot A. So the only place where the angle can be is here. So let's say that this is angle A. So it's in quadrant 3. Next, let's check. This cot A is 1 over tan theta. So 1 over tan A will be 5 over 2. So, so tan A will be the inverse of that, 2 over 5. With this, we can find a coordinate, a set of coordinates that lie on this line. So, since tan A is opposite over adjacent, we can say that the opposite is goes on the y-axis, the adjacent goes on the x-axis. So, so this will be so opposite over adjacent, so the y over x. So one of the coordinates that lies on the line is, so y is 2 and x is root 5, but the signs need to be negative because this side is negative x and this side is negative y. So negative root 5 and negative 2. So we know that. So one of the points is negative root 5 and negative 2. Now let's find the hypotenuse. So we can use the Pythagoras theorem. So one of the sides squared plus the other side squared, is equal to the hypotenuse squared. We can also say h. We can also say h as r, because technically over here we have this, and we're measuring the ratios on this circle, and this is basically the radius. So we can put r, and then we can find r using this. R is a root of x squared plus y squared. That is the root of x is root 5 and y squared is 2 squared. So r is going to be root of 5 plus 4. So r is 3. Now what we have, this is 3 and this is negative root 5. This is 2. So we have this x, this y. Oh, this y should be -2. And then we have this radius as 3. Now we can find these which we originally wanted. So first let's find cosec A. So cosec A of A would be 1 over sine A, which is 1 over y, the opposite over the hypotenuse r, which is r over y. So it would be 3 over -2. So you can also write it as -2 over -3 over 2. So this is cosec of A. Now the other thing we wanted is the sec of A, which can be written as 1 over cos theta of A, which is 1 over, so the adjacent over that we have the hypotenuse r, r over x. The r is 3, and the x is -√5. We can also write as -3 over √5, or we could also rationalize it by multiplying both by √5. You would get -3 √5 over 5. So that's it for today. Thank you.